All right, guys, so this is a mass spec problem that comes up fairly often on AP chemistry exams and tests. And it's asking about a molecule and how many peaks that you would see if you took a mass spec, of a sample of this molecule. So in this case, we have boron trichloride. And what we're told is that boron, there's actually two different isotopes of boron, and there's two different isotopes of the chlorine atoms. And so when they form molecules, they're going to combine in different ways. So in a naturally occurring sample of boron, it's going to have these two isotopes. In a naturally occurring sample of chlorine atoms, it's going to have those two isotopes. And so it's asked, how many peaks would we see, and what mass would each peak be? And so to figure this out, there's various ways that you can do it. But if you want to just brute force this, you can think of it this way. You can say, okay, so if I have a boron 10 bonded to three chlorine atoms, then I can put chlorine 35 in that column, and I could put chlorine 37 in this column. And so it could be a boron 10 bonded to three chlorine 35s, 2, 1, or 0. And then for the 37, it would look like that. So we always have to have three chlorine atoms. If we have less than 3 of the chlorine 35, then the remainder has to be the chlorine 37. And so each one of these will be a peak. Each one of these will give me a peak in my mass spectrum. And you can do the same thing with boron 11. That's a really messy looking B, my apologies. Do the same thing, and it'll look exactly the same. So we have 3, 2, 1, 0, and 0, 1, 2, 3. Okay, and so right here already, we know that we could possibly have 8 different peaks. These 4 combinations here, these 4 combinations here, but we'll only have 8 peaks if they all have different masses. And so that's the other thing that we need to check, and it's not hard to do this. You can think of it as just adding up the mass numbers for each of the isotopes in the boron trichloride molecule. So in this case, I'll have 10 due to the mass of the boron, plus 3 times 35, because I have 3 of the chlorine 35 atoms. And in this case, I would have a mass of approximately 115 AMU. It's not going to be exactly 115 because the actual mass in AMU is not a nice whole number, but it gets you the idea. And then you can kind of go down here, and I'll write this one out. But so we'll have 2 35s plus a 37. Okay, so essentially my mass will have gone up by 2. Instead of having 3 chlorine 35s, I now only have 2, with one of the chlorine 35s replaced by a 37, which is like 2 AMU heavier. So this one is going to be 117 AMU, and this will be consistent. So this one will be 119 AMU. We gain another 2 AMU, and this one will be 1, 1, 2, 0, 2, 1. This one will be 1, 2, 1 AMU. Okay, so those would be the 4 masses of the boron trichlorides with the boron 10. We can do the same thing over here. Again, we're just checking to make sure that we're not going to have masses overlapping together and that we will have 8 different peaks. And so for this one, it'll be 11 plus 3 times 35. That'll just be one more than we have over here. So this will be 116. And again, we're going to be going up by 2 because we're replacing 7 there. We're replacing chlorine 35 with a 37, so this will be 118, 120, 122. Okay, and so looking at these, what we're seeing is that there is no common mass, right? So in other words, we're not going to have 2 of these molecules kind of overlapping under the same peak. And so the answer to this problem would be that, first of all, we would have 8 peaks. Okay, we have 8 peaks, as we figured out up here. And then these will give you the approximate masses of each peak, which, being a bad teacher, we have our units here, don't we? These will give you your masses for each of those peaks, and that is how you answer this question.